Hello, I'm Kathleen, and today it is my honor to share with you how at Northwestern we're redefining vaccine design through nanotechnology and a new concept that we call rational vaccinology. Today, we live in a society that is plagued by chronic diseases. Consider heart disease, diabetes, and cancer. These make up the top 3 leading causes of death in our country. And if you look at cancer alone, just last year, there were more than 2 million new diagnoses and 600,000 deaths just in the US. Now, we are already familiar with the conventional ways that are used to treat cancer, such as chemotherapy, surgery, and radiation. However, as anyone with a loved one who's battled cancer knows, these treatments can be invasive and cause severe side effects, ultimately leading to a tremendous physical and emotional burden to both the cancer patients as well as their families. And as such, there remains an urgent societal need to develop more effective strategies to treat cancer. Today, I'll tell you about immunotherapy, which is a promising new pillar for cancer treatment. Immunotherapy is unique in that it harnesses our body's own immune system to specifically target and kill cancer cells. And by doing this, it provides a much more durable response, as well as greatly minimizes the side effects of treatment. Now, you may have already heard of immunotherapy, as it was used to cure former President Jimmy Carter of cancer. Back in 2015, President Carter was diagnosed with stage 4 metastatic melanoma and given only a few weeks to live. He was then prescribed a cancer treatment plan consisting of chemotherapy, surgery, and immunotherapy. And after following this plan, he was then declared cancer-free within a few months. And while its promise as a cancer treatment remains strong, the major problem with current immunotherapies is that they're largely ineffective when used as a standalone treatment. And here at the IIN, we recognize this as a major opportunity because nanotechnology has the power to transform this field. What nanotechnology allows is the ability to precisely control the structure and components of therapeutics in a way that can only be achieved at this nanoscale. With this capability, nanomedicine researchers are making rapid advances, especially towards the development of vaccines. Now, we've already seen the power of nanotechnology in action back in 2020 when Pfizer and Moderna developed nanoparticle-based mRNA vaccines for COVID-19. The speed of development and efficacy of these vaccines was unlike anything we had seen before, and now more than 12 billion vaccines have been administered for COVID. And this historic achievement was recognized through the 2023 Nobel Prize in Medicine. Here in the Mirkin lab, we're leveraging nanotechnology and vaccine design, but now in this new direction geared towards cancer. In our lab, we invented a unique type of nanostructure called a spherical nucleic acid, or SNA, which in simple terms is a globular form of DNA. SNAs are about 100 nanometers in diameter, or roughly 1/1000th the thickness of a sheet of paper. SNAs possess a unique set of properties that make them poised for vaccine development. And in the context of a cancer vaccine, we utilize a special sequence of DNA known to stimulate the immune system, referred to as an adjuvant for the shell of our SNA. We also utilize a portion of a cancer protein as an immune system training element, or antigen, as a way for our vaccines to specifically target the cancer cells while leaving the healthy cells intact. Now, the beauty of our approach is that one can systematically modulate the structure of our SNA vaccines and easily tailor them towards different forms of cancer. Our SNA vaccines have taught us something really important about vaccine design, and that is that structure matters. It's not just the choice of adjuvant and antigen components, but rather how they're structurally presented that dictates the overall vaccine efficacy. And this is the notion behind the emerging field of rational vaccinology. This idea that structure matters and may be as important as that choice of vaccine components. So to visualize this and really hammer home this point, Imagine if we thought of the vaccine components as a pile of Lego pieces. Now we could build many possible structures from the same pile of Lego pieces, such as a house or a castle, for example. And we all know between the two structures, the castle can offer better protection against foreign invaders. And if we relate this back to vaccine design, we now know from rational vaccinology that we can take the same vaccine starting components and build them into different vaccine structures that vary in their level of efficacy or protection against foreign diseases. Now we've seen this in action here in the Mirkin lab as we've made small yet precise nanoscale changes to our SNA vaccines and observed profound impacts on their overall efficacy, in some cases transforming a vaccine for cancer from ineffective to curative. Now here at Northwestern, we're working hard to establish the design rules that make the most effective vaccines, because as it stands, this notion of rational vaccinology has the power to change the way the world thinks about designing vaccines, not just for cancer, but across all of medicine. So as you can see, the research we do here in this group is extremely exciting for me and is a major reason that I came to Northwestern. I truly do not take for granted the opportunity I have here at the IIN to work in this extremely collaborative environment, bringing together the greatest minds spanning from chemistry, biology, material science, and more to really tackle these big issues in the world. Lastly, none of this would have been possible without generous donations from the Ryan family, the Willens family, and the Ed Bacharach Foundation. And for that, I'm sincerely grateful. Thank you.